Hello class, this is Mr. Lamb. We're back with part 2 of our stoichiometry. We're going to start to set up some basic 3-step math-to-math classic stoichiometry problems in this tutorial. I gave you a graphical organizer after I told that cheesy story in class about stoichiometry though. And so this graphical organizer can be your best friend as you initially start out setting up these problems. So today we're going to take a look at going from mass. I apologize, this image is bogging down my computer. So if you're given like how many grams of something reacts, and you basically want to go to the other side, you want to figure out how many grams of something are produced from this many grams of something reacting, we can't just go from mass into mass because atoms weigh different amounts, so we can't quantify things that way. So our job in stoichiometry is always to go from grams, if we're provided the mass, into the number of moles. This is always going to be step 1 in what we call a mass-to-mass stoichiometry problem. So go from grams of the known chemical, and I'll show you what I mean by that, into moles by dividing by the molar mass of the known chemical. And then once you have the number of moles of the known chemical, that allows us to quantify it. We're going to take a look at our balanced chemical equation, and we're going to multiply by the ratio of how many moles of the unknown can be produced by how many moles of the known. By doing this conversion, by going from here to here, multiplying by the ratio, that will give us moles of unknown, what we're trying to find out. And then our last step then, so this is step 1. This here is step 2. The last step is to then convert back into mass. And we got to do that by multiplying by the molar mass of our unknown, which is typically a product, but it doesn't have to be a product. It could be the other reactant, or we could work out the product and go into the reactant. So let's apply this. Alright, so before we looked at water. So this typically oxygen is plentiful, and so a question might be like this: if you have excess oxygen in an environment and you react 5 grams of hydrogen gas with excess oxygen, how much water can you make from that? So this is a synthesis reaction. These two things are combining to make water. If we have excess oxygen, that means we have plenty to go around. It's not going to be a factor in how much of our product we can make. So I like to put a white line through it so I eliminate it from my sort of view, and I know I don't need to worry about that when I set up my problem. And it helps limit any mistakes I can make. And so what do I know? I start out with. So I know I'm reacting 5 grams of hydrogen gas. So I take what I know and put it over top of 1. That's how we set up our dimensional analysis problem. So we're going to use a lot of dimensional analysis this unit. I like to also label, well, what chemical is this? This was hydrogen. So I like to label the chemical formula because I'm going to be working with 2 chemicals in the same equation. So it's very easy to get distracted of what I'm doing or what's what. So not only label grams or moles, but also label the chemical formula. And you'll find that to be very helpful in limiting the mistakes that you make. So that's step 1, or that's setting up the problem. Step 1 is to take the mass number of grams and divide it by the molar mass. Figure out how many moles of hydrogen I have. So that's what we're going to do here. So we're going to take 1 mole of hydrogen with how many grams? There's 2 hydrogens. I don't look at the coefficients here. I just look at the chemical formula, so it's H2. So when I do the mole mass, it's H2, 2 hydrogens. Don't worry about the big numbers. And so 2 times 1.01 grams, 2 hydrogens would have a molar mass of 2.02 grams. The grams of hydrogen will cancel, leaving me with moles of hydrogen. The next step is to look at the ratio, right? The ratio. So the unknown, what is the unknown? This is what we're trying to find out. So I look at what coefficient, what ratio of waters I can make to my known, and there's a 2-to-2 ratio. So this one is easy. It's how many moles can be made of what I'm trying to find out, which is water. It goes on top. The moles, how many moles I'm starting with is the known, which if I start out with hydrogen, goes on the bottom. So there's a 2-to-2 ratio. So from 2 moles of hydrogen, I can make 2 moles of water. The moles of hydrogen cancel. So that's a clue too. Match up your units. Units have to cancel. So what's on top here has to be on the bottom here to cancel. If it's on top, then you're going to multiply it and square it, and that is disaster, right? We want to avoid that. So units have to cancel. The last step then is to multiply by the molar mass of our product. And so our product is H2O, so you know that 1 mole of H2O, I know the mole of H2O part goes on the bottom, is equal to 18.02 grams. 16 for the oxygen, 1.01 for each hydrogen times 2, so it's 18.02. Once again, I don't factor in that 2. That 2 is how many of that chemical I have in the equation. It's not the chemical formula. The chemical formula for water is H2O. So I set the problem up here, so I'm going to go ahead and pull out my calculator, and let's see what we get. So 5 divided by 2.02 times 2 divided by 2 times 18.02 is equal to 44.603 grams. This here only has 3 sig figs. This is one of my measurements. And so if it has 3 sig figs, my answer can only have 3 sig figs. So I can make 44.6 grams of water from reacting 5 grams of hydrogen with excess oxygen. All right. So let's do another one. Hopefully here. Repetition, seeing it again and again is going to help you pick up on the key skills here. So actually look at the one that we did before from last tutorial. So let's do another very similar type question. So let's say we have excess oxygen in the air again, so we're outside and we're burning ethane. If we burn, let's say, 10 grams of ethane, and we're worried about global warming, greenhouse effects, so burning hydrocarbons gives off CO2, and that's linked to trapping heat in the environment, in the atmosphere, which could, in theory, lead to global warming. If you buy into that, there's a lot of evidence to suggest that, but that's a whole other day, right there, a whole other topic. So let's see here. So what do I know? This is my known. This is excess. I don't worry about it. Water's not mentioned here at all. It's a byproduct. We're not worried about that. What am I trying to find out? I'm trying to find out grams of this, so this is my unknown. So I'm going to take what I start with, 10 grams of ethane, put it over top of 1, and then I need to go from mass into moles so that I can quantify and relate quantities of these 2 different chemicals to each other. So I need to say, divide by the molar mass. The way I use that or set that up in dimensional analysis is 1 mole is equal to, we had 2 carbons, 12.01 apiece, 24.02, plus 6 hydrogens at 1.01 apiece, 6.06. So we have 24.02 plus 6.06, so we're looking at 30.08 grams per mole. All right, so that converts into moles of the known, so I need to cross over the river to get to the other side, and so to pass through the moletroles, I need to tell them how many moles of unknown I made. And so the unknown, so CO2, there's 4 moles of CO2 produced from 2 moles of my known, so it's a 4-to-2 ratio. So moles of C2H6 cancel, and now if I solve that now, I have moles of carbon dioxide. But the question asks for grams, so we have to convert from moles into grams by multiplying by the molar mass. So that is what we're going to do here. So we're going to multiply by 44.01 grams of CO2 for 1 mole of CO2. On some numbers on our calculator. If it's on top, you multiply by it. If it's on the bottom, you divide by it. So 10 divided by 30.08 times 4 divided by 2 times 44.01, and we get as an answer 26, and we can keep 4 sig figs, 29, I'm sorry. 29.26 grams. CO2. Alright, there you go. Two basic, classic 3-step stoichiometry problems, grams of known into grams of unknown. In future tutorials, we're going to get a little bit deeper, have some slight variations to this process. So I'll see you soon here. Tutorial 3 will be up soon.